Hello everyone, welcome to Z Intelligence, and today we're going to continue from the last class. In the previous lecture, we've talked about the combinatorial meaning of the three very useful tools in counting. And a good news is, so far we've actually completed all concepts in counting this chapter. And later on, we're just going to focus on problem solving. And if you look at my schedule here, we still have 6 lectures left for this chapter. And I'm gonna tell you, they are really the key parts of this series of videos. Because to make these videos, I've actually looked at the past 10 years IB paper and summarized all counting questions into these 6 lectures. Which means you will never find the same thing in other videos. And after watching this series of videos, you will have a great chance to get a 7 in your accounting test. Okay, today we're gonna begin the first one, which is special elements. So far, we've actually practiced a lot of counting questions, and a lot of time we're permuting elements in the same status. What I mean by that is, for example, I'm permuting 5 people. 1, 2, 3, 4, 5. I want you 5 to line up. Even though I know they are different people. Like some of them are girls, some of them are boys, some of them are stupid, some of them are smart. However, none of them is really special here. Because I can pick any of them into any of the place I want them to sit. However, sometimes we're gonna have some trouble kids. They are special, really special. For example, this one is the leader of the 5 students. So if I want to arrange these 5 students and want to make this person always stay in the first place. Now I can definitely see the difference, right? This person is definitely the special kid, the special element among these 5 kids. Because we have to pay some extra consideration to the person when we are arranging them. Now, you know what I mean by special element. And let's have an example to reinforce our understanding. Okay, so here let's look at this example, which is a really very typical example of special element. It's asking us to find how many 5-digit numbers can be made by using, these 6 numbers from 0 to 5 without repetitive digits. This is actually pretty similar to the questions we've done a lot of time before, but why this question has a special element? First, let's take a review on how did we solve the similar question before. Before, I know that I have 1, 2, 3, 4, 5 places, so I'm going to choose a number for each of the places separately. So I'm going to do that stepwisely, which means I'm going to use multiplication principle. However, this time, there is actually one of them, one place is special. I'm going to give you 3 seconds to think about this. Which place is special? The correct answer here is the first place. This is a really special place. Let's think about it. Why? First of all, I know the 5-digit number, the first one, it will be the leading digit. And I know that leading digit can never be 0. So, the first place, it actually has a restriction here. The restriction is can't be 0. And make it special from others because for 2, 3, 4, 5, these 4 digits, I can choose whatever I want. But just for the first one, it can cause some trouble. So this time, I know that the first one is special element, but how do I deal with it? Luckily, we actually have a master key that can solve almost every question that involves a special element. Which is, we always gonna begin with the special element. You're special, so I'm gonna deal with you first. After you are done, there's nothing special, so I can do what I did easily. So let's see, how do we actually apply this method? I have 5 digits, so I'm going to break the step into 5 process. And in step 1, I'm going to deal with the special one, which means I'm going to choose a number for the first place. Okay, I have 0 to 5, 6 numbers. However, it can't be 0. So how many ways can I do this? I have 5 ways to do this process. Okay, I'm done with the special case. So later on, I can just do what I usually do with this kind of question. We can choose a number for the second place. Choose a number for the second place. And here, how many ways can I do that? Well, it says, this time, I cannot use the same number again. In the first step, one of 1, 2, 3, 4, 5 is used. Let's say it's 2. So for my step 2, how many ways can I do that? Well, I have 6 numbers, but 1 is used. So this time, I'm going to have 5 choices. So complete my step 2, I actually have 5 ways as well. And later on, it will be exactly the same thing. In step 3, we're going to choose a number for the third place. Okay, in step 2, one more number is used. Let's say it's 0. So this time I only have 1, 3, 4, 5, these 4 ways. So to complete my step 3, I have just 4 ways. So do you find a pattern? For step 2, I have 5 ways. Step 3, I have 4 ways. So reasonably, for step 4, I'm going to have like 5, 4, 3 ways, right? And then it's 2 ways, and then it's 1 ways. Okay, so according to multiplication principle, I'm going to multiply every step together. So step 1, I have 5 ways, and then it's 5, 4, 3, 2, 1. So I'm going to multiply 5 times 5 times 4 times 3 times 2 times 1. Okay, and then the question is done. That will be everything for this video, and now let's take a summary on what we learned. In this class, we learned the first question type, which is a counting question involves special element. How do we really define special element here? According to the previous example we did, I know that a special element will just be something that has some extra restrictions than others. With extra restrictions. Okay, how do we deal with special element? Well, according to the rule we learned, we're always gonna deal with the troublesome, deal with the special case. Special element first. Okay, so that's the end of the video. If you find this is helpful, please give me a subscription and like. And let's see you in the next video.